Welcome back, students. Today is the session 1 from the chapter of current electricity, and this is the introductory session. In this session, I will be discussing about the generation of electric current. So, on this board, I have written 4 bullet points to start with. The first point is it is basically the definition of electric current. So, what is electric current? Electric current basically it is the flow of electrons. So when the electron flows in a conductor, the electric current is generated. Second point is the direction of this conventional electric current is taken to be the direction of flow of positive charge. This is the second point. Third point is the electric current flows from a higher potential to a lower potential, because you see here the direction of this conventional electric current is taken to be the direction of flow of positive charge. Now the positive charge always flows from a higher potential to a lower potential. Therefore we can say that the direction of the electric current is that is we can say that the electric current flows from a higher potential to a lower potential. And the fourth point, which I think everybody knows, that electric current is a scalar quantity and its unit is unit in the SI system. In the SI system is ampere, and 1 ampere is equal to 1 coulomb per second. So this is the unit of the current in the SI system. In the SI system, the unit of the current is ampere, and 1 ampere is equal to 1 coulomb per second. So now we will be discussing about this topic in detail. So I will try to explain the concept of this electric current with the help of this example. Here I am making one figure here in which I am connecting a small conductor to an external EMF source. This is the positive terminal and this is the negative terminal, means this is at a higher potential, this is a lower potential. So this point, you can say that this point is at a higher potential. Let us say I am taking this point as A and this is the point as B. So this point is at a lower potential and this point is at a higher potential. So, and this is a metallic conductor. Let us say I am taking an example of a copper conductor. Now, each and every material in this universe, it is made up of atoms. So similarly, this is a copper conductor, so it is made up of atoms. It has got a certain atomic structure, and the atomic number of copper is 29. Now, so we can now, the atomic number of the copper is 29. It means the number of electrons is equal to 29. Now, we know that in an atom there is a nucleus, and the electrons, they revolve around the nucleus in orbits, and for a stable configuration of the atom, the number of atoms in an orbit is given by 2n square, when n is the nth orbit. So if the number of electrons in the copper atom is 29, then in the first orbit the number of electrons will be 2, in the second orbit it will be 8, in the third orbit it will be 18, and in the last, that is in the fourth orbit, the the number of electrons in the fourth orbit will be 1, because 18 plus 2 is 28, and so in the last orbit, that is the fourth orbit, the number of electrons will be equal to 1. Now for an atom always tries to have a stable configuration, and for that purpose it will always try to have 8 electrons in its last orbit. Now here you can see here that this copper atom has got only one electron in the last orbit. Now it is easier for this copper atom to release this one electron instead of gaining the 7 electrons. So what happens that when this conductor is now placed in an external electric field. Now I have connected this conductor to an external EMF source. Now this is at a higher potential, this is at a lower potential, so the direction of the electric field will be this. It will be from a higher potential towards the lower potential. Okay. Now because of this electric field, what will happen? This electron will be subjected to an electrostatic force. And because of this electrostatic force, now the as we all know that the negative charge, the direction of force on the negative charge is opposite the direction of the electric field. So the electron will be experiencing an electrostatic force in this direction. Okay, the electron will be experiencing a force. Let us say I'm writing it here as Fe. The electron will be experiencing a force in the opposite direction of this electric field. And when this and what happens that because the atom always tries to attain a stable configuration, what it will do is that this electron will get released, and when it is released, it is called a free electron, and the movement of these free electrons constitute an electric current. So the electrons will start moving in this direction. Now, when this electron is released from the atom now becomes a positively charged ion, because now it has got a deficiency of, because the number of electrons now is equal to 28 and the number of protons is 29. So now it becomes a positively charged, you can say, ion or a particle, and the positively charged particle, it moves from a higher potential to a lower potential, and it will be experiencing the force in the direction of the electric field. So this positively charged ion will move in this direction. It will be moving in this direction. Now by convention, as we have just discussed, that by convention, the direction of the conventional electric current is along the direction of flow of the positive charge. So the positive charge, the direction of the positive charge is in this direction. So the direction of the current, the direction of the conventional electric current will be taken in this direction. The electrons will flow in the backward direction. So now in the steady state, that is when the electric current is uniform, in that case, in the steady state, if the net amount of positive charge passing through a cross section in time interval say t is q, then current I is equal to q upon t. That is, in the steady state means when the magnitude of the electric current is constant. So in the steady state, if the net amount of the positive charge which is passing through the cross section of a conductor in a time interval say t is q, then current I is equal to q upon t. Let us say this is one cross section here. I'm just taking here as this is a cross section, and I am just denoting it as a dash. Now if the net amount of positive charge which is passing through this cross section uh, uh, in a time interval t is q, then I is equal to q upon t. So this is the equation in the case of a steady state. Now, however, the current never flows in a steady state. So in that case, we can say that in the case when the current is not steady, then if delta Q is the net amount of charge passing through a cross section, passing through a cross section in time interval delta t. In the case when the current is not steady, then if delta Q is the net amount of charge which is passing through a cross section, say a dash, in time interval delta t, the current I will be given as IT. Since the current is not steady, therefore I am writing it as IT, that is, this is the current at any moment of time. So current at any moment of time will be given as limit delta t tending towards 0, delta q upon delta t, which is equal to dq upon dt. Okay? So this is the equation when the current is not steady. In the case the current is steady, then I is equal to q upon t. And when the current is not steady, then the current at any moment of time is given by limit delta t tending towards 0, delta q upon delta t, this is equal to dq upon dt. So, uh, whenever a conductor is placed in an external field, then the direction of flow, the conventional current, is taken as the direction of the flow of the positive charge. So here in this case, the direction, the current is flowing in this direction because the positive charged ions, they are moving in this direction, The current always flows from a higher potential towards a lower potential, and the electrons, they flow from a lower potential to a higher potential. So now this is the basic definition of the electric current, and I have here just tried to explain you how this electric current is generated and what are the different equations which will be used while solving the questions in the forthcoming sessions. So thank you very much for joining in this session. In the next session, I will be discussing about the Ohm's law. So till then, have a nice day. Bye.